Let's start. Okay, so the wavelength, we are discussing about the wavelength. So I was asking that I was saying that wavelength is equal to the propagation speed multiplied by period. We know what is period, we know what is wavelength, but the question is, what is the propagation speed? What is the propagation speed? Propagation speed. What is it? What is the meaning of propagation? Okay, propagation means whenever you travel from one point to another point, either is through the air or wireless or through the any media. If you travel from one point to another point, that is called propagation. All right. So propagation speed means how fast you can travel from one point to another point. That is called propagation speed. Generally, in data communication, whenever we are thinking about propagation speed, that is actually the speed of light. Okay, speed of light. But okay, and it is defined by c. Okay, what is the speed of light? Speed of light.
3 into 10 to the power 8.
Yes, 3 into 10 to the power 8. Yes, what is the unit? Meter per second. Yes, correct. That means the light can travel 3 into 10 to the power 8 meter in 1 second. Very good. So this is the propagation speed multiplied by period. So we can write that lambda is equal c multiplied by t, because t is the period, and we know that t equal to 1 by f. So we also can rewrite the equation by lambda equal to c by f. Fine. So that's how we can find out the wavelength of a signal. Okay. Generally, okay, let me ask you, before I explain it, let me ask you, let us consider, okay, let us consider these two signals. No, these two signals are same. 1, 2, 3. Almost same. Anyway, let's consider. Anyway, it will be difficult for you, but let's try. Look at these two signals. Looking at these two signals, what do you think, which one wavelength is higher and which one wavelength is lower?
The first one is higher.
Wavelength, remember. Wavelength.
The second one is the second one. Second one.
Why second one?
Because its propagation is more than first one.
You are saying that the second one's wavelength is bigger than the first one.
Yes, sir.
Okay, what is the reason you said that in one cycle or in one period it can travel longer distance than this? That is the reason, right?
Yes, sir.
Okay, yes, explanation is correct, that if you can travel more distance than any other one, that means your wavelength is higher than any other signal. By the way, can you find out what is the frequency of these two signals? Let's consider this is 1 second. Let's consider they are same time, this and that is 1 second. What is the frequency of these two signals? 1, 2, 3. What is the frequency? If you can find the frequency correctly, you may change your answer. Although the way you are thinking was correct, that's why I said correct. But if you think about, if you can find the frequency properly, I think you can rephrase your answer or rethink your answer. What is the frequency, both of them? And just assume that
3 hertz.
both of them has the 1 second. What is the frequency? 3 hertz.
3 hertz. Yes, sir.
3 hertz. So if they are having same frequency, do you think that their wavelength is different? Huh?
So wavelength is different.
No, sir.
Okay, that's why I said that this is a little bit critical. I think, let me help you. Let me give you a very simple one. Let's consider these two cycles. These two signal. All right, easier for you, less confusion. Now think about these two. Which wavelength is bigger?
The second one.
Second one, of course, second one, right? Of course, the second one wavelength is
Yes,
bigger
sir.
because in one full cycle it can travel longer distance than this, because in one full cycle it can travel only this in one full cycle. But here, in one full cycle, in one period, it can travel longer like this. What is the frequency of this signal?
3 hertz.
3. And this one?
Percentage is 3.
1.
1. So what? So this is the frequency is 3, and the frequency this is 1 is 1, and the wavelength is bigger this one, but the smaller this one. So what is the relationship you can find out between the frequency and the wavelength?
If wavelength is bigger, then frequency is lower.
Exactly. If the frequency is lower, your wavelength is bigger. If your frequency is higher, your wavelength is smaller. That's why whenever we saw the equation, whenever we have the equation of lambda, look at the equation of lambda, that generally we have divided by the f. So whenever you have so whenever your frequency is bigger, that means your wavelength is smaller, because we are divided by f. So if f is bigger, of course your lambda will be smaller, and if your f is smaller, of course your lambda will be bigger, according to the equation, and we can see that, right? So that is the relationship I actually just want to explain, but very good that you can find it out. Very simple thing to find out that. Please remember that whenever your frequency, generally whenever your frequency is smaller, that means your wavelength is your wavelength is bigger, like this. Whenever your frequency is higher, your wavelength is smaller. Fine. Okay, so let's go to the equation. We have can you remember this table? Milli means -3, micro means -6, nano means -9, and pico means -12, whereas the kilo means +3, mega means +6, giga is 9, and tera is 12. You have to memorize this table. Otherwise, it is impossible to do the math, what you are going to do now. Do you need time to memorize it, or is okay?
It's okay, sir.
All right,
Time to memorize it.
fine. So let's just check the equation first. We will do one example, and you will do 2 exercise. So let's do checking the exercise. So this is our equation, f equal to 1 by t, or same way, t equal to 1 by f. We know that t equals the period of the time, and f is the frequency of that, sorry, t is the time period of that signal, and f is the frequency of the signal. Okay, let's have the example. Very, very simple. So the example is, the power we use at home has a frequency of 60 hertz. That means the alternate power, alternate current, AC current we are using at our home, the frequency of that signal, of that power, is 60 hertz. What does that mean, 60 hertz? Our alternate current.
Its frequency F is equal to 60 hertz.
Yes, and
God is drawing the battery.
okay, I have to charge you. Fine. Okay, what is the? Is it charging? Yeah. So actually, what does it mean? 60 hertz. That in 1 second we have 60 full cycle, right? In 1 second we have 60 full cycle. If whatever we are using at our home, although the voltage is 200 to 240, but the frequency is 60 hertz. Okay, so the question is, that is the information. Question is, the period of this sine wave can be how we can determine it. So very simple. This is t. So we need to find out the, no, sorry, this is f. We need to find out the t. So we know that t equal to 1 by f. So this is the answer. Listen very carefully. This question does not ask in any particular unit. So if you just write 0.0166 second, that is the answer. You don't need to convert it into millisecond if the question didn't ask you to do it. Please remember that if the question would not ask you to any answer it to any particular unit, you don't need to convert it. Our standard is second and hertz. All right, because our time is second and frequency is hertz. That is our standard unit. You don't need to change it if the question is not asking to change it. Fine, because if you write the wrong unit, I told you before that it will be the total math is wrong. That means you will get 0 if only the unit is wrong. So if you are not sure about the unit, this the best option is do not write it, because if you do not write the unit, the whole math will not be wrong, but you will get 50% marks at least. So 50% marks is much better than 0. So please, if you are not sure about the unit, do not write the wrong unit. Fine, because if you write the wrong unit, the total thing is wrong. So please be very careful. Okay, so that is the example number 1. Let's see another example. Very simple. It says that the period of a signal is 100 millisecond. Okay, now the period time is given in 100 millisecond, and it is asking what is the frequency in kilohertz. Okay, so that is the two things. It is the new one. The given time is in millisecond, and I told you that we have to do calculation in our standard format. That means in second, but the value is given in milliseconds. We have to convert it into the second. First thing. Second thing, it's asking what is the frequency in kilohertz. I told you our standard is hertz, but the question is asking in kilohertz, so we have to convert it from hertz to kilohertz. Fine. So it is also very simple. This is our t. So t equal to 100 millisecond, and we know that milli means -3. So 100 into 10 to the -3 second. That is our standard format. Now we can do the calculation. F equal to 1 by t. That is our t, and we have the answer is 10 hertz. But the question is asking what is the frequency in kilohertz. So we have to convert it from hertz to kilohertz. That is another confusion. Okay, when you convert from a smaller unit into the higher unit or bigger unit, we have to divide it. We have to divide the value. For example, if you have a 1 gram, if you have a 1 gram and I ask you to convert it into 1 kilogram, what you are going to do, you have to divide it, right? You have to divide by 1000 from gram to kilogram, because you are converting from smaller unit to the bigger unit. So please remember this theory. Whenever you are converting from a smaller unit to the bigger unit, you have to divide. Fine. Opposite, if you want to convert from the bigger unit to the smaller unit, you have to multiply. For example, if you have 1 kilogram, and if I am asking that what is the gram, Then you have to multiply by 1000 to make it from kilogram to gram. So whenever you're converting any unit from bigger to smaller, you have to multiply. Whenever you convert a unit from smaller to bigger, you have to divide it. Very simple rule. Although it is looks and seems like very simple, it is really not simple when you are going to do it by yourself. That's why we are going to do practice. Two math we are going to do practice now. So by the way, it's very simple that we have 10 hertz, then it's divided by, because it's hertz to kilohertz, kilo is 1000, that's why we are dividing 1000, that's why this is our result. Fine? Any confusion? Any question so far? No. If there is no question, then we can check another one, which is the time domain and frequency domain. Did we discuss this one, time domain and frequency domain? No, baby, right? Okay. Okay, so what is the time domain and frequency domain is, as we know, whenever we represent any signal, right, most of the time we represent our signal in this way, in wave format. So whenever you represent your signal in this way, wave format, so we have x-axis and we have y-axis. So generally the y-axis is always the amplitude and the x-axis is always the time whenever you have this wave format. Fine. So that is called time domain. Time domain representation. That means we represent the signal in time format, in time domain format. That's why we call it time domain. So the y-axis is amplitude and x-axis is time. So if you represent your signal into this format, we can call it is a time domain representation. On the other side, if you represent the same signal in amplitude and frequency, then it is called the frequency domain representation. Only difference is the y-axis is same, the only difference is the x-axis. Previously our x-axis was time, now our x-axis is frequency. So that's why previous one is called time domain, this one is called frequency domain. That is the definition. Let's see how you can convert it from here to here, from time domain to frequency domain, or frequency domain to time domain, how you can convert. One more thing, you can represent any signal by using either one of them. You can represent any signal by either time domain or frequency domain, okay, and both of them should be same. For example, you are watching this one, this we have three frequency here, so this representation, and we also have a 3 frequency here on B, both of them are same, exactly same. Let's see how it is same. So look at the blue one, this is one of our signal, and this is our 1 minute, sorry, 1 second, this is 1 second, and this is our signal, so you look at the blue one, blue signal, how many full cycle it has in 1 second for the blue signal? Blue one, this one, how many full cycle?
0.
0, correct. The blue signal does not have any full cycle in 1 second, so that's why the frequency of the blue signal is 0. That's why this one, whenever you convert it, the frequency in the x-axis is 0. Now check what is the amplitude. Amplitude is 15. So amplitude is 15. So that's why you have just one spike. The frequency is 0 and the amplitude is 15. Just one spike. Fine. Look at the pink one. This is 1 second. How many full cycle we have? If you count, you can find there are 8 full cycle in 1 second. That means the frequency of the pink one is 8 hertz. So if you convert it in the y-axis, it is 8. Then the next one, what is the amplitude? The amplitude is 10. That's why the amplitude in the y-axis is 10. Previously it was 15. So you just need to have one spike. Fine. Third one, the green one. Same way, how many full cycle we have in 1 second? If you count, it will be 16. 16. So that's why the frequency is 16, and that's why we have one spike in 16. That is, the frequency is 16. So let's check what is the amplitude. Amplitude is 5. So the amplitude is 5. Every time you have to check x-axis and y-axis, the value of x-axis and value of y-axis. Then absolutely simple. So we check first one, what is the x-axis? X-axis is frequency. So for the three different frequency, we have three different frequency like 0, 8, and 16. So we put into the x-axis, and then we check what is the amplitude. Amplitude is same, 10, 15, 10, and 5. So 15, 10, and 5. So that's how we can represent. And as I told you before, these signals and that signals, both of them are same. And we can represent any signal by either the time domain or frequency domain. So you might thinking that the frequency domain is easier. Why we need to have a time domain? The answer is most of the time, because by looking at this one, you cannot analyze it. So to analyze the signal, most of the time, we need to have a time domain. But generally, frequency domain is much more easier to understand and much more easier to calculate. But sometimes we need to analyze the signal or the characteristics of the signal. So in that case, time domain is better. So it's entirely up to the developer or the user or the engineer that which one he prefer to do the analysis, either time domain or frequency domain, and both of them are same. Fine. Any question?